So we're wanting to know what is the slope of f of x equals x squared plus 1 at the point negative 1, 2. Well, in order to do that, I'm going to start each problem off by writing the definition of the derivative out. F prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. So from there, I want to know what f of x plus h is. Well, if I wanted to know f of 2 is just 2 squared plus 1, right? So f of x plus h is x plus h squared plus 1. So that's f of x plus h, and then I subtract from that f of x. Well, this is f of x. So it's minus x squared plus 1.
Wait, so
Over h. I'm listening.
so the slope would be the f of x plus h, and then you should do the what's outside the slope.
No, all of this is slope. This is my change in y's. These are y coordinates, right?
Yeah.
So these are change in y's over change in x. So the entire thing is the slope.
Oh, okay.
This is just,
Oh, I didn't see the squared on it.
okay. So you're better now?
Yeah, I think so.
All right. So f prime of x is the limit as h approaches 0 of. All right. Now, if I'm at this step right here and I plug in 0, I get 0 over 0, which again, we talked about when we hit 0 over 0, that runs into a situation where there's probably a limit that does exist. So we're going to look at how we can simplify this out. Best way to simplify this out is just to square it. All right, x plus h squared. Remember, it's not x squared plus h squared because you're multiplying x plus h times itself. So it's x squared plus 2xh plus h squared, then plus 1, then distribute the negative in. So it's minus x squared minus 1 all over h. Now, at this step right here, if you're dealing with polynomials, when you get to this step right here, if it does not have an h in it, it should cancel out. If it doesn't cancel out, then you've done something wrong in the problem. So let's look and see what doesn't have an h in it. Okay, we got x squared, right? Does it cancel out with anything?
Mm-hmm.
What? Negative x squared, okay. So these two go and play with the dodo bird. That's a technical math term.
Positive 1, negative 1.
Positive 1 and negative 1 go away too. All right, so now everything has an h left with it. It's still the limit as h approaches 0 of h times 2x plus h over h. Well, by factoring out that h, what does that allow us to do?
Cancel out the 2.
Cancel out those. So it's now the limit, and you're not going to have to show all these steps, but I'm trying to show them for now.
Mm-hmm.
H approaches 0 of 2x plus h. So now we don't get something undefined because we don't have a denominator. There is no denominator to equal to 0. So now we can plug in 0. So we get 2x plus 0, which is just 2x. So my general derivative for x squared plus 1 is 2x.
Why are we using f prime?
That is the notation for the derivative.
Okay.
All right? Well, what are we interested in? We're interested in this slope at the point negative 1, 2. So f prime of x at negative 1, 2 is 2 times, and notice your coordinates are negative 1, 2, but the derivative doesn't have a y value with it. So it's just going to be 2 times negative 1, which is negative 2. So my slope here is negative 2. Now, I'm going to add one thing to it. I could have asked this for the 0.01. I could have asked this for the 0.24. We don't have to do this anymore. We don't have to do this work right here. Once we've established that the derivative for this equation is 2x, now all we have to do is know the x coordinate for the point, and it will give us the slope for that particular equation, not every equation. If we come into, like, if this had been x squared plus x plus 1, now we would have to start it back over, because that graph would behave differently and have different slopes at different values.